Hello everybody! Today we're going to be taking a look at how to write the function or write the equation given a description of what we want the graph to do. So if you've been paying attention to our four little formats or forms that we've been using to graph parabolas, we're going to be using those depending upon the description that we're given. And we're going to be writing our own equation of something that's already been graphed. So we're just going to start with some examples here. It says, write the quadratic equation for the parabola shown. You don't need to draw the graph in your notes. If you just want to write down some key features, that'd be fine. I have a spot here for key features from the graph. There are some key features here. I'm noticing that I have a vertex that's listed here as being at -2, -3. And I'm also noticing that I have some random point here, 0, 5, and that's more than just a random point, it's actually the y-intercept, but we're going to use it as sort of a random point here as we do our calculations. And our goal here is to write the equation, write the y equals something, something, something for the parabola that would go and hit these spots as shown on this graph, or hit those key features. To do that, we're going to use one of our forms, or one of our general equations that we've been writing here in our little foldable and working with as we've been graphing. So see how I've given something here about the vertex? That's my clue that I'm going to use the vertex form. The general vertex form is y equals a x minus h squared plus k. That's on the front of our foldable. This is a general equation that we can use to plug in things and help us solve to figure out what the equation is for this graph. Now, if you remember, the vertex is given by these numbers here. So if I go ahead and plug in just the vertex right now, I have y equals a x, and if I plug in minus a -2 squared, and then plus -3 is the same thing as -3 here. So if I simplify that, I have y equals a x plus 2 squared minus 3. So I've plugged in my vertex so far, but there's still this weird little a thing here that we need to figure out, or we need to solve. The general form has an a, but most of our equations might have a 1 there, or a 2 there, or a -1 there. We need to figure out what that value is going to be. It's that value that determines just how low this parabola dips. Okay, and we need to figure out what that value is for this graph that we're given. So how do we do that? Well, we've used the vertex, we've already plugged it in. This random point now becomes important to us. The random point has an x and a y value that we can plug into our form that we have so far here. I'm going to plug in the y is 5, I'm going to leave the a, x plus 2 squared minus 3. I want to plug in the y and I want to plug in the x here, so I'm going to erase my x, make that a little better. My x value is a 0. So now everything's plugged in except the a. The a is something we don't know, but now we can figure it out. So I have the 5, I have an a, 0 plus 2 is 2, so I'm calculating this, and squaring it is 4. That's a times 4 minus 3. That's the same thing as saying 5 equals 4a minus 3. So if I was going to solve this, you'd see I'd add the 3 over, and I'd get 4a equals 8. So a would be 2. This tells me that the a that I'm looking for, the value in front here of this vertex form, needs to be a 2 in order to make the parabola hit the spots I need it to hit. So I'm going to go ahead and finish my general form, y equals 2 in front, x plus 2 squared for the vertex minus 3. Okay, so that 2 value is the a that we're solving for to try to make our parabola hit where we need it to hit. Let's do another one like this. Write the quadratic function for this parabola shown. So again, I'm going to just steal some key features off the graph here, try to figure out what the key features are first. I'm looking and I'm seeing some key features here. I see x-intercepts this time. So I see an x-intercept at -3, and I also see one at 2. So it crosses at those two places. And again, I see a random point at -2, -4. So I have x-intercepts this time. That's the clue that I'm going to use intercept form here to write this equation. So y equals a something I don't know, x minus p, x minus q is intercept form general formula, okay? And now we're going to plug in everything we know. Well, we know the intercepts are at -3 and +2. So I'm going to go ahead and plug those in here where I see the p and the q. Y equals a, x, plugging in, there's a subtract sign, then I'm going to plug in -3. Well, that's like adding. Okay, x minus the 2. So I plugged in the x-intercepts where they go. And then I'm going to plug in the random point. So I plugged in these guys. Now I'm going to plug in the random point. Every random point has an x part and a y part. So we'll go ahead and stick those in. The y is -4 equals a, plugging in the x part of the random point, -2 plus 3, and another x part, -2 minus 2. Now we can go ahead and calculate this. This side over here is -4, still have an a. There's multiplying here. -2 or plus 3 is a 1. And then -2 minus 2 is a -4. So if I go ahead and figure out what's happening here, I have a basically times -4, so -4a. And now if I solve for a, dividing by -4, dividing by -4, a equals 1. So I know that in front of my general form here, to finish it up, my a value has to be a 1. So my final equation would be y equals 1, where the a usually is. And then my parenthesis would be x plus 3, because that gives me an x-intercept at -3. X minus 2, because that gives me an x-intercept at +2. Most of the time when we graph these, this little 1 was not here. It was just kind of implied. But you can have it there if you want to, or not, either way. Okay, let's do one more here. So we're writing a quadratic function with the vertex at 2, 1, and it passes through the point 0, 4. So we have a vertex again. So this time we're going to use the vertex form. So I'm just going to copy down what the vertex form looks like. There's the general formula for vertex form. And then we'll go ahead and plug in what we know. If I'm going to have a vertex at 2, 1, that means that I'm going to plug in the 2 and the 1 for the h and the k. So my general form now turns into y equals a x minus 2 plus 1. That's just plugging in the vertex part. The 2 and the 1 get plugged in there. I'm going to put the squared back on them. Now the vertex has been plugged in. Now I'm going to plug in the x and the y from random point. So 4 is the y, 0 is the x. And now when we calculate that to simplify, we get 4 equals a. And we'll take a look at what's happening here in the parentheses. 0 minus 2 is -2. Squared is a 4. So this is the same thing as saying I have 4 equals a times 4 is the same thing as 4a plus 1. We'll go ahead and subtract the 1 to get the a by himself. 4a equals 3. A equals 3/4. So that tells me that when I plug that a value back in, take them right back up here, y equals 3/4 is the a value I need, and x minus 2 squared plus 1 still gives me the vertex that I need. So this is the general equation that if we were to graph it would meet these characteristics that we're looking for. Okay, we're going to spend some more time working on this later, but that gives you a general idea of what's to come. Thank you for taking some good notes today.